So you will get your first, your exam will be week 6. This is currently week 4. You will get your practice exam next week, which will be a good approximation of the exam. The exam will primarily be going over, if statements, for loops, and turtles. So basically all the stuff that we've learned so far. You'll get a very good idea of what's in there when we go over the practice exam. So I'm going to start off fairly simple. I'm also just right now at the moment not going to work in idle. That's okay, just because I have this open. So let's see. Okay, status, compiler. Yeah. So then the point being is that you don't have to work in idle to do anything or to do everything in this class. So really today I'm kind of bored and I want to draw rocket ships. So that's what we're going to do today. And of course that's not going to have any, that's of course going to be in no way relevant to what we're doing. Right? No, I've got a plan. Totally got a plan. So let's call this rockets.py. Okay? And I'm just going to start by coding here. So and we're going to just kind of start with basically with the old ASCII art we were doing, which is just basically print statements, right? Print statements basically, let's see, how should a rocket ship look? It kind of looks like this, right? Where we've got this cone kind of thing going on here. Yeah, let's go ahead and print. Oh, and we'll need to do double slashes over here because, of course, we need the escape character. Right? So that could be the cone for our little rocket. Print. Right? And there's no need to copy this down at the moment because it's going to get a bit messy. Based on the amount of times I'm going to basically cut stuff up. Right, and that would draw basically a triangle. So let's go ahead and draw like some more sections for this thing. Let's do some equal signs over here. Also, now that I'm working in this editor, you may notice that my font does a couple of weird things, such as if I put 2 equal signs together, it will merge them into one big equal sign. If I put 3 of them together, it does that. No worries about it. All right, it's 6 across because that one doesn't actually show up. Right, let's see what we have right now. Is that big enough for everybody to see in the back? Should I increase the font size? Let's see, preferences for the terminal. Large was not large enough. 26. 24, 28. That should be plenty big enough. Select, boom. There we go. So let's go ahead and continue making this rocket ship. Again, we'll do the quiz closer to the end after we've gone through this whole thing about rocket ships. We'll take a bit. So next is like a rectangular section for the rocket ship. So, and as you'll notice that I'm doing a lot of copying and pasting here. Right, so here's a kind of a section for that. And then here's a section for that. Right, pretty big rocket ship, I think. And then let's just make like the rocket tail, which is honestly, if I just take this part over here and put it on the bottom like that, we've got kind of a rocket, we've kind of got a rocket tail over there. And then if I do a print, if I do a print like that, maybe that works. Let's see how that looks. Oh, unexpected end of file. That meant that I didn't put that in. So there, right, we've got our rocket ship. Right, it's fairly innocuous and boring, but there's a lot of things that we can do to make this a bit better. One is that we can make this a bit better by defining each of the parts of the rocket ship by using a function, right? So for instance, I copy pasted this section a whole lot, and then I reused this down here. So there's no reason why basically I can't make those functions to make it a bit easier to read when I'm analyzing our code. So let's do that. Again, a function is just our way of adding a new command into Python. We do def. Let's do def triangle. And I'm right now saying it's taking in no parameters. We're going to deal with the parameters today. By the way, if you might start getting the hint, this has a bit of, we might be moving towards applications towards your current lab. It's almost like there's a method to this madness. And what we do is that we're going to take this triangular thing over here, and we're going to move it into this function. And I'll delete that section. We didn't need it. And then we're going to take this rectangular bit. Oh, I'm like, why isn't it doing anything? It's because it was just cutting it up and moving and shifting it up the exact same amount. So def rectangle takes in no parameters, and I'll just go ahead and indent all these guys, and then I'm going to delete that, and then I'll do for our last bit, I'll do def exhaust. And I will just simply print, well, we can actually do some variation there. Before our exhaust, right, it's 1, 2, 3, 4, 5, 6. And now I'm going to use the insert key to actually make this a bit easier for me to do, which is we will do a bar over here, and then I'm going to copy this, and then insert key over here, and then there. And what I'm going to do is I'm just going to make a wavy motion by doing that, I think. I'm not very good at ASCII art, but I'm good enough, I guess, so to just mess around with it. And that should look like just a small little exhaust trail just coming out of the end of it. So, actually, let's do it like that. So now we've got basically our components of our rocket ship right now. 3 basic components. We can add in more as we go on, but right now that's good enough to start with. Okay, the triangle and the exhaust are going to be the easiest parts. The rectangle, as we'll see, we're going to make a bit more difficult. But now all I have to do this is that I can just do triangle. I can call triangle for the top, and then I can do for blank in range rectangle. Call the rectangle command, let's say 3 times, and then do another triangle, and then do the exhaust. Okay, and now if I print this out, right, I said it printed out the triangle, and then we did 3 rectangles, and then we had another triangle down here to kind of be the booster kind of thing of it. And then here's my exhaust. And if I wanted a bit of a longer exhaust stream, right, what I could do instead is that I could do for blank in range, and then I could just declare how big of an exhaust stream I want. So if I want it to be like saying that we've traveled a long distance already, I could put in 5, right? And now it kind of just waves back and forth, with an exhaust stream just being this pattern right over here, right? And now that they're connected, it looks like it's repeating, which is really nice. Okay. But it's a very narrow spaceship, if you want my opinion. So, but everybody understand this whole idea of basically what we did with the creating new commands, and then we called them here. Now, typically what we do is that, like, if we want to do something like that, we might make another program, like we might make another function called build rocket, like over here, and then just put that all in here, right? Makes sense? And then we might call that down here, build rocket, and then you see, basically, so we've got this new command which calls the other new commands we built. That's perfectly okay. I should also mention, though, that and so you can have commands that call other commands that call other commands, just like create, and it can, that can work. I should point out, though, that there are some issues that you can run into. For instance, spam, print spam, okay? And then if you have your spam method or spam function, then call spam on itself, right? It's not gonna, Python's just gonna be okay, sure, but anybody have an idea of what's gonna happen there? Yes? Probably. Yeah, it's basically saying that, so it's just going to print out basically forever until it hits the point where the computer says, well, so every time you do a function call, it's got to keep track of what called it, right? And eventually what's going to happen is that, and it keeps track of that in what's called the runtime stack. And then eventually what's going to happen is that you're going to fill up that runtime stack so much that it's going to overflow, and you're going to get what's called the stack overflow error. So that's what happened there. We just kept doing that. Similarly, you can get into a loop like that if you do something like this: def eggs. Right. So we have spam, we have eggs here, and we're going to print eggs, and then we're going to do spam over here, right? This one calls this one, which calls that one. You're rarely going to accidentally write that, by the way. You're probably never going to accidentally write that. But same thing happens, right? We're just calling spam eggs, and then it says maximum recursion depth. That's where you have functions calling it themselves, essentially. That's what recursion is. And we'll get, oh, sorry. We'll get into that much, much later. But back to this. Now, typically, what we might do over here is that when we have a main method that basically builds everything together, we might not actually call it like build rocket. We might actually give it a name and call it main instead. Typically, a lot of programming languages, they will basically, the main method is called main. In fact, Python does have a special way of dealing with main that we'll see later. Well, that I'll explain later, but what it will typically do is it'll look like this. If name, it looks like vaguely mysterious and annoying. If name equal main. I think that's how you do it. No, it's not how you do it. If name equals underscore. Is that it? Yes. And that's basically just Python magic that says, hey, if you're running this class, run these. If you're running this Python file, run these. But for right now, we're just going to run it like a script. Def build rocket. Right? Because I want to be able to have a bit more granular control over the pieces. Again, because I might want them, right now, this isn't really particularly, fun. So let's go ahead and work on the triangle a bit. I want to be, so right now, the rocket is width 6, right? It is 6 characters wide, right? 1, 2, 3, 4, 5, 6 characters wide. Would be really nice if we could have a variable amount of width. So let's start with the triangle, right? Instead, I would like it to be a certain amount of width. So when we add in a parameter over here like this, we're saying that basically that we're making a promise. We're going to provide the triangle function with an input called width. And it promises that it will use that in some way, shape, or form. But we're only promising that we're going to give, and we're promising we're only going to give it one parameter. We're not going to give it any less. We're not going to give it any more. So we're going to provide it with a width. You can name it whatever you want, but it's generally good to give it a meaningful name so that when you come back in a week, you actually remember what's going on. So we'll call it width. And so obviously this should probably make a bit of sense, which is basically if it's width 4, sorry, if it's like, if we give him width 4, we'd like to do this. If we've got him width 6, we'd like to do this. And if it's width 8, we'd like it to be wider, right? If it's width 2, it's just going to be this, right? The width is going to be the width of the rocket. So basically, does that make sense? I see a couple lost faces. Basically, if the bigger the number, the bigger the rocket. Or rather, the fatter the rocket. So we give it a width, and right now, though, how do we get all these print things going on? Well, we need to use a for loop and vary basically what's going to happen. So let's think about this. Each line of this tip of the rocket is split up into actually 4 separate parts. You've got your spaces that are before the slashes, you've got your slash, you've got some amount of spaces between the slashes, and then you've got a slash. And the spaces, now we're always going to have one slash or another slash, right? We're always going to have the forward slash and the backslash, right? But the amount of spaces in between, that's going to be variable. So the first thing we need to figure out is how many lines we need, right? So if it's going to be width, so first off, if it's going to be width 4, we're going to need 2 lines. If it's going to be width 6, we're going to need 3 lines. If we've got 8, with 8, it's going to need how many lines? 4. It's going to need half. It's going to need basically half as many as the width is. So we'll write a for loop. For line in range width. And you can call it whatever you want, but because we're going to be printing each line individually in the for loop, we're going to be using, I'm going to call it this. Now width, not width, right? Width would be basically, that would be, in this case, 6 lines. But what I'll do is I'll do width divide 2. Make sense? Why divide 2? Because I want an integer there. And then what I need to do is that I need to focus on printing out each of those individual parts. And I'll keep these outside. I'll comment them out right now, just so that it matches, so we have it for reference. So each line now that we've got a for loop, we're going to be looking at this in terms of each line. So the first thing I need to do is print out some number of spaces. That seems hard. I'm going to leave it to later. So then I need to print out and I'm doing this wrong right now, but that's okay. So I'll come back to this in a second. But I need some number of spaces. That seems hard. I'll just put 1 space and come back to it later. Then I need to print out a slash. Then I need to print out some number of spaces, which again, I don't know how many that's going to be. That seems hard. I'm going to print out 1. And then no matter how many, no matter how wide the line is, right, I always know I'm going to print out 1 slash of each type. Like so. So now if I print it out, I got to call build rocket again. I'll be back up to there. And also, a big part of doing it in functions and splitting up the functions like this is that it makes it a lot easier for us to work on a specific part. Triangle missing 1 positional argument, width. So we have to add in a width over here. So we're going to do 6 for our triangles. Okay, Oh, that seems wrong. That seems very, very wrong, right? I should have gotten 3 lines, and instead I got 3 times, like 15 maybe? I don't know. A lot. So what happened here is that the print command, it was 12 lines. So print here, by default, what does print do? When we run print, every time we do a new print, it goes to a new line, right? That's the default behavior of print. So we can specify how we want print to behave by using another argument called the end argument. And that works by saying end is equal to what we want to do. The most common use of that is to say n. Now by default, this is the way it looks. /n. Suspected spam caller. /n. Right, which will just print a new line, which basically says we print out the thing that we want to print out and then print out a new line. What we'll want to use is empty string, which says don't go do anything after I print out what I want. I'm going to be connecting a bunch of stuff. So here, right, if I do it like this and like so. And now you notice that, oh wait, it's all in one line. Well, what happened there is that everything got connected, and then it would go on to the next iteration of the for loop, and there's nothing separating each loop. So what we'll do over here is that we'll say print, now that we're done at the end of each line, we're just going to print out an empty line. And run this. And we've now got a space. So now our triangle looks like this. A space, a slash, a space, a slash. But that's just doing exactly what I told it, right? Which is good. So now what we have to work on is getting our spacing right. Okay. Now, fortunately, Python does have things that make this a lot easier than in other programming languages. But so I'm going to show you the easy way, and then I'm going to show you how we do it with nested loops, okay? Because one of your assignments says you got to use nested loops. So what we need to do is, oh, and I should point out, basically, now if we change this to triangle like a 10, it will do 5 lines of triangle now, which is nice. But now we need to get this back to working with going back to what we're doing, which is if we need to get the proper number of spaces. So let's start by thinking about how many there are in each of these. So if my width is 6, then I have 2 spaces here, 1 space here, and 0 here. Or another way to put it, on line 0, I have 2 spaces. I have 1 space here, and I have 0 spaces here. That seems a bit tricky to figure out. What about the middle one? What about the spaces in between the slash, which is over here? Well, over here I have 0 spaces. Over here I have 1 space. Not 1 space, I have 2 spaces. And then over here I have 4 spaces, right? 0, 2, 4. How many spaces should I have? So let's go ahead and experiment. If this was instead a width 8, because all these are a pattern, and it's just a matter of finding the pattern. So if if this was width 8, then it would be 0, 2, 4, 6. 1, 2, 3, 4, 5, 6. Make sense? So it's going up by 2 each line. Okay. So what we can do is that let's see what happens if we multiply this by line. Right? Line being the variable, what line we're on. 0, line 1, line 2, line 3. So it's starting to vary over here. 0, 1 space, 2 space. We need, though, twice as many, right? right? Let's go ahead and make a table, which is generally what I think is the best way to do these. Okay, which is that if the line is 0, 1, or 2, or 3, then how many? So I'm going to call this before and then middle, which is how many spaces we need in each of those lines. So and then we're going to see if we can't find the pattern. Right? So so on line 0, right, if we've got, let's go ahead and stick with basically being width 8. We would have, how many spaces do we have over here? 1, 2, 3. We have 3. Then we have 2. Then we have 1 space. Then we have 0 spaces. On the other hand, for the middle, we would have 0, 2, 4, and then 6. So we can try to generalize this out into a pattern of some kind. So if we have n spaces, well, no matter what, it's going to end up being, so if we have n, if it's n width, and we're on the nth line, the last line, say, last line, so it's going to be 0 before spaces, but how many would be in the middle on the last line? It's 2 times whatever the most amount of line is. So for the nth thing, it should be 2 times line. And then we aren't sure about this one yet, but that's fine. 2 times line. Why 2 times line? Because line 0, we have 0. Line 1, we have 2. Line 2, we have 4. Line 3, we have 6, and so on and so forth. So now if I run this, we'll see that it's starting to get there, but we don't have our preceding spaces yet. Okay. Now for our preceding spaces, we know that basically we're going to start off between, let's go ahead and actually move this out and make this an easier to read variable. Lines, the total number of lines I need is width divided by 2. So for line in lines. This is just going to make it easier for me to write it down. For line in lines. That changes really nothing. All I did was store this in a variable. But it's going to make it easier for me to write. Line, so we have 3, 2, 1, and then 0. So it's decreasing the total amount. Now, we know for 6 lines, so if we have 6 lines, we'll have 2 spaces. If we have 8 lines, we're going to start out with 3 spaces. So why don't we try, but it seems to be basically what we're going to be doing is we're starting with some number and we're subtracting each time we go through. So why don't we try that? So we're going to go with lines, and then we're going to subtract the current line from it and see what that does. Oh, that seems to be really close. But what's the issue? We should have 0 lines on the first space. So what happened there? Right? Lines is always a static number. Right? That is the total number of lines. But line is the current line we are on. So the total number of lines minus our current line, so that's going to be 3 minus 0, so 3. 3 minus 0, 3 3 minus 1, which is 2, 3 minus 2, which is 1. So we're going to keep subtracting here. Now, it doesn't line up exactly because we've got one too many lines. Oh, sorry, we've got one too many spaces over here. So what should we do since we have one too many spaces? Any suggestions? We've got one too many. Yes? Subtract 1. One too many spaces, subtract 1. And look. But that's not proof that it works. What we need actually is to kind of show that it will work for size like 20 or something like that. So that seems to work, right? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a grand total of 10 lines. 9, 8, 7, 6, 5, 4, 1, 5, 4, 3, 2, 1, 0. And that fits the equations of lines minus line minus 1. Or another way to put it is line minus the current line plus 1. There's a lot of ways you can write that. But now we have something that goes by a specific width. Now, how do you turn this into a nested for loop? Well, the idea here is that with a nested for loop, we could print out it's not particularly hard for space in range. So how many spaces do we need to print out? What we're doing over here is we're simply saying we're going to instead print out each space one at a time rather than print out one big clump of spaces. But all you need to do that is just take what you multiplied by and put it into range. And now it's turned into a nested for loop. Except that I need to put what did I forget? I forgot a colon. But I think the other way is easier to read, so we're going to keep it this way. Okay, so now let's move on to spaces. Sorry, to our rectangle. Okay. So our rectangle is fairly straightforward, right? It's also going to take a width right now. And then we might alter it later to produce a height as well. Okay? But for right now, we're going to do a width for things, right? Right now, it's a 6 by 6 thing. That's fine. And it's a lot simpler of a shape, right? What our rectangle has is that given a width, the top is always going to be width number of characters long. Right? So so the top of the rectangle is always going to be this equal sign. It's always going to be width number of equal signs. So that's fairly straightforward to do. Print width equal sign times width to get the number of those, and then end, so that equals nothing, so that it connect. Oh, actually, we don't need the end is equal to nothing. We don't put end is equal to nothing because we're printing out an entire line there. And then similarly, we'll want another one of these for the bottom, right? This is the bottom. This is the top, right? And then we have 4 lines in between. So we don't have a variable amount of lines yet for the box. 4 blank in, well, let's go with 4 line in range 4. And what we need to do is now print out these things. Now this is actually a lot easier to do. Each of these lines has a fairly straightforward component, right? It is print a bar end equals because we were going to connect that bar to the rest of the line. Print some number of spaces, which will figure out the number of spaces. This one's going to be a lot easier to figure out. Print, and then print another bar. End is equal to connect it, except we're not going to connect it to anything because we're done, and so we'll print an empty line at that point. So now if we do rectangle, so now the rectangle is going to need the width. So we will need to do 20, 20, and then 20. So, right, this makes sense. We just told it to do 20 and then 20. And then we need to actually have a certain amount of, we need to figure out how many spaces we need between the bars. Right? So if the width was 6, we needed 4. If the width is 7, we need 5 between the bars. If the width is 8, we need 6 between the bars. So how many bars do we need? Yes? Yep, width minus 2. Basically, however, and that makes sense, right? Basically, we could print out width number of spaces, but 2 of our spaces are taken up by the bars. So what we'll just do is multiply by width. It's very important, by the way, that you put this in parentheses over here, because otherwise it's going to do space times width, which will give us 6 spaces, then try to subtract 2 from 6 spaces, and that you can't subtract from strings. You can add 2 strings together, or you can multiply a string by a number. So now we do that. We've got like a jumbo rocket going on there. And the exhaust doesn't actually look too bad from where it is. So we've got ourselves a nice jumbo rocket there. We can also add in another variable, though, to here. We can add in a height. So let's go ahead and add in a height, basically saying that for the rectangle, I'd like it to be maybe, right now, as it stands, we're just doing we had 6 by 6, right? So it was 6 lines tall. I'd like a bit more to that. But that's not really too much of a change, because that's just simply the total number of lines. So we have 1 line for the top, 1 line for the bottom, right? Top, bottom. And then we have a number of these sections over here. So how many is that? That's going to be height minus 2. Because we've got because height is the total number of lines. Subtract 1 for the line of bars. Subtract another for the second line of bars. That was a fairly easy edit to do. Fairly quick, painless, right? And you have to add in a second variable over here, because if you don't, it's going to be very mad at you, right? So if you add, right now rectangle will only work with 2 variables. I should point out, by the way, that this is a bit of a issue, that now we're getting into a bit of a annoyance, because if I want the triangle to be, if I want the rocket to be like 50 width, then I have to change 50 over here, 50 over here, and 50 over here. So any suggestions as to what to do for that? I can put in a width variable over here and say 20 over here, and say, and now basically I only have to change 1 variable in 1 place to make a rocket of a different size. Right? So now I only have to change this, because this will copy 50 over to here, which will copy 50 to here, here, and here. Right? It says, oh, wherever I see width, I'll replace it with 50. Likewise, we can also do a height. And do that over here. $30 by 50. And now it's a very, very big rocket. All right. So now let's go ahead and work on the exhaust portion of this because we haven't touched that yet. Okay. So that one's a bit tricky. So first off, width, right? Now we're going to go ahead and assume we still want just 4 lines. So 4 blank in, so 4 line in 4. In range 4. What we need to do, and then this is split up into 3 parts, right? Which is print a space, or print some number of spaces, print a bar, and then print another some number of spaces. Let's see, 1, 2, so, and I need to widen this. 1, 2, 3, 4. Although if I think about this actually, let's see, so let's see, 1, 2, 3, 4, 5, 6. Yeah. I don't actually need to print out any spaces afterwards, right? Because they don't actually do anything and they don't actually show up. So it's really just print some number of spaces and then print a bar. And I could totally just do this so that it will print that and then go to the next line. I was just trying to be a bit explicit about everything. So let's see. With 6, I needed 1, 2, 3 spaces beforehand. Then 2, then 1, then 2. That's what's going to make it tricky, this kind of alternating thing going on. So 3, 2, 1, 2. And this is a lot trickier than any problem I'd give you because of that alternation that goes on over there. So let's try and see. So we've got 3 lines. So let's see. Well, we're subtracting again, so let's try our old technique of width of, or rather, let's say we've got 4 total lines. So how about 4 minus? Well, the 4 minus width won't necessarily work because what do we want to do? We want this to end up in the middle of the rocket, right? So right over here we had 1, 2, 3, and then we had 1, 2, 3. So we had basically, so this would be what? Let's go ahead and mark the indices. 0, 1, 2, 3, 4, 5. Index 3, then index 2, then index 1, then index 3. If, on the other hand, this was with 8, then it would need to be like this, where it was 4, 3, 2, 1. So what we need is that, so it's really dependent on what the width is. So let's see, width. So what is the width over here? The width would be 8, and we want this index over here. So width divided by 2. Divide by 2 minus the current line. So let's see what that would give us. That would give us width minus 2, divide by 2. So 8 is our width. Oops, sorry. 8 divided by 2 is our width. So 8 is our width, divide by 2 gives us index 4, minus 0, So that gives us 4. Next line, 8 minus 2. So 8 divided by 2 minus 1 gives us 3. Then we'd subtract over here. And then we'd add over here. And then we can get over here, and that's a bit tricky. So there's a couple ways to do this. The first is to just simply do it as an, but let's go ahead and just see what we've got right now. Whoops. Missing positional argument with, right? We need, so we need to put in with over here. So right now we've got the descending pattern. What we need is this to be over here so that it connects each of those. So it looks like a trail of exhaust going out. So what we could do is that we notice that basically this formula works for everything but the very last item. So one thing you can do is that, well, if it works for everything but the last, then we're just going to have to handle the last one special, won't we? So in which case we just simply say we're going to print out 3 lines. Okay, makes sense to everybody? We'll print out 3 lines, and then we'll handle the 4th manually, which is honestly mentally the easiest way to do it, because it doesn't involve any messy formulas or anything. We just say, okay, width divided by 2, this one needs to be at width divided by 2 minus what? So it needs to be, width divided by 2 will give me 4, minus 1 will give me 3. So width divided by 2 minus 1 should make that work, right? Basically taking your generalized formula you came up with and then plugging in the specifics. And we notice that that works. We print out 3 lines according to our formula, and then we do the 4th manually, because that 4th one breaks the pattern really severely. Because the only other way I can figure out how to do that is using modular arithmetic, and that seems like a real mess. Or doing an if statement of some kind. And that would just end up being the same as handling the case specially. The modular arithmetic, again, would probably be a mess. But this is a good example of sometimes we need to, have an exception over here. So let's go with a height of 20 and a width of 8. And we'll notice we get a very long but narrow rocket. So hopefully this makes sense in terms of applying for the lab that you guys are working on. Let's go ahead and do this, do something similar, but with turtles now. And then we'll go ahead and do our quiz, which does not concern turtles, but this will carry over, right? So let's go with nested stamps. All right, over here. So I'm going to go ahead and say this. This problem I gave, I did in last spring. I did it in class. Then I also gave it on the exam. Then I also gave it, or something similar to it, on the second exam. Well, actually, I didn't do this one on the second exam, but I gave it in class. I did it on the practice exam, and then I also gave it on the exam. So that should give you a nice indication that there's probably going to be something similar to this on the actual exam. So, import turtle. We're going to create Bob as we normally do. Turtle. Okay, and then we're going to do Bob.shape is equal to Bob.shape is a turtle. And then Bob.shape size is equal to 1.5 just to make him look good. And then we're going to do, I'm actually going to do something a bit weird from the very beginning, which is Bob.penUp. I'm having him put his pen up. All right. Now the pattern that I'm going to draw over here, let me tell you what I want, because that will give you a good idea of what, that will leave you less mystified as in programming. So what I'm trying to do over here, and because I'm very terrible at drawing turtles, I'm just going to draw X's, right? I will just, so the pattern I'm going to do is I'm going to do this with my turtles. I'm going to have him stamp once over here, twice on over here, 3 times over here, 4 times over here, 5 times, and so on and so forth. Right? I suppose I can do that as a method too. So I will do that as a function. Def stamping. Okay, and right now we'll just simply do this as, and then I'll call stamping over here. Okay, Bob, so stamping will create a turtle, set its shape to turtle, set its side to this, and then do Bob up. And then we have a for loop. For line in, and I want to do 5 lines of this. So for each line, I want Bob to move forward. Well, I want him to stamp once. So Bob dot stamp. And then I want him to, let's go ahead and do like the 3rd line over here. Bob dot stamp, and then he should move forward. And then he should stamp again, move forward and stamp again. So 3 lines total. And you know what? For less questions, I'll assume that Bob starts over here in this position. So he's going to move forward, stamp, then he's going to go back, then he's got to go down to this line, move forward, stamp, then go back to the next line. Okay? So what we'll do is we'll have Bob move forward. We'll have him move forward 50, and then we'll have him stamp. Okay? And then we're going to have Bob do move backward 50. Bob dot left 90. Wait, no. Right if I wanted to go down. Turn right 90. Bob dot forward 50. And then Bob dot left 90. Right? Move forward, stamp, then move back, move forward. We're only doing 1 stamp now. We're going to need him to do multiple stamps. Okay? But to do that, we're going to need a nested for loop. So move forward, stamp, then have him, after he does his stamping, have him move backwards, move right, then turn right, move down, and then get back in position. So let's see how this works out. What did I forget? Colon. Very common mistake for me. No module named turtles. Import turtle. And you'll notice it closed almost immediately. That's because I was doing it outside of idle. To handle that, to keep it from closing when the turtle's done animating, if I'm not working in idle, because I noticed people were having this issue, and this is the primary reason I'm working outside of idle today, is that you just have to add one more line called turtle.done. And that should keep it from closing until you actually close this window. So he did that 5 times. But I want him to do a variable number of stamps. So I'm going to adjust the line from being 0 up to and including 4 to being 1 through 5. 1 to 6. Just to make my counting a bit easier here. So we're going to start at 1 as opposed to 0 this time, because I can do that if I want to. And so because now if this is lines 1, 2, 3, 4, 5, as opposed to 0, 3, 4, 5, 6, 0, 0, 1, 2, 3, 4, I just need him to move forward and stamp the exact number of times that we have for the line. So for stamp in line, or actually let's not call it stamp, but for step in line, we'll have Bob move forward 50 steps and then stamp, or not line, did that wrong. Range line. So for line in range 1 to 6, what we're going to do is we're going to have him move forward. And then we're going to have him, let's see. We're going to have him move forward. And we'll have him stamp. Then we'll have him back up. Now, mind you, we can't have him move back up just 50 this time around, right? Because he's going to move forward 50 on the first one, then 60, then 100 on the second one, then 150. So we need him to move forward 50 times the current line number. That makes sense to everybody? And now what we can do is we can make this, as our last step before we take our quiz, we can make this variable. So we can do a total number of lines over here. And have this lines plus 1. And let's say we want 10 of these. And now we'll do 10. So some variation of this basically having a turtle basically do things in lines and then having a different number of things be on the line will be on the exam in 2 weeks. Right? This kind of thing will be on the exam. If not this exact thing I just wrote. So just a heads up there. Probably be worth 10 points or something. Last time I did this, actually, it was what I actually did is I gave most of the problem, and then I basically had most of the commands, and then I had I had you fill in the blanks for this or something similar. So just FYI there. So, all right, let's go ahead, and now that we're at the end of class, let's go ahead and do that quiz that I have that I've promised you guys that you're so looking forward to. So, if for some reason you, so this should be fine. Log in. And again, the quiz will be on, like you can take it on the phone or on your laptop. The quiz is the for loop quiz. So it's for loops 1. And the access code to it is 141. One of the questions we're gonna have to grade manually, but that's okay. So and then so this will be fairly straightforward. Let's see. And let's go ahead and just do one thing fairly quickly over here. Since I do think it's a bit more difficult than normal, I'm going to just change the rules for it just slightly. First thing is that I will, let students see their correct answers. Let's see students see the correct answers. No. But allow multiple attempts. Highest time. And let's say if you have trouble here and you want to study more, you can have another 2 attempts at it. Okay? Sounds fair? Because I feel like this one's a bit harder, but I also feel like it's important. But the point of quizzes is that they should not stress you out. They should do the opposite of stress you out. They should give you credit for participating and learning. Oh, and one last thing. So after the changes for Runestone, one thing I figured out about the thing that I'm going to send out a more detailed email, for you to get credit for the readings, you have to hit mark as completed. and then your score doesn't update until you go to the page and hit Score Me. So once you hit Score Me, it will update your score. And you can hit Score Me as many times as, so you can do a bunch of prompts and you can hit Score Me. Yes?
It's just that sometimes when I try and do that, like there's some pages of the reading that literally just say at the bottom, mark this repeated once. And those pages always say I have 0 out of how many points.
All right, if you can send me a screenshot of that specific one, that'd be great, because I think I changed them all to be, if you interact with it, then you get credit for it. So it could be that you just have to hit Score Me again after I made that change. Again, this is my first time using it. And also if I notice that everybody, like, I'll go through, like, after we do the first exam, and I'll look at the, like, amount of points that they give. If I notice that everybody's got, like, 97% and nobody has 100, or everybody has 80%, then 80% is going to be the cap. So it's not something to worry about. Right? It's, again, my first time using this, and I thought it would be painless. I thought wrong, but. So I'll give you guys until like 3:13 before I make some final notes. So edit, it shouldn't be, so, right, it should be asking you to enter a passcode.
Yeah, it did the first 2 times.
But this time it's not. And it's not locked. It says lock this quiz now over here, so it's not locked. You can, I mean, if you're okay, if you're comfortable with it, you can take it at home now that you've been here and had the password for it, right? There's 3 attempts on it, so you're. Mm-hmm.